Okay, so I'm going to make a start. So good afternoon, everyone. Thanks for coming to hear us talk about leveraging artificial intelligence for business intelligence.
Hi, my name's Dan. I'm a junior data scientist for Advancing Analytics. I've been working since February for them. I'm a real maths geek and a problem solver, so that's me.
Okay, I'm Gavita Regunath. I'm a principal data scientist at Advancing Analytics. I did my PhD in fluid dynamics, but I did had the opportunity to use AI to investigate how fluid mix in gas turbine engines. Ever since then, data science has been my passion. So in my spare time, when I get some time for myself, I dabble in Kaggle competitions. I'm not sure if you guys know about Kaggle. I'm also a STEM ambassador, so I really enjoy going into schools and talking about AI to the young technologists. Okay, as Dan mentioned, both of us now work for Advancing Analytics. Advancing Analytics is a UK-based consultancy, and we deal with all sorts of analytics problems, really. For the size of the company that we are, I'm very proud to say that we've got 4 Microsoft MVPs within the company. We are also Microsoft Gold partners and partners with Databricks. So just a thank you to all our main sponsors, gold sponsors, silver sponsors, and supporting sponsors. So just to start our talk, really, I wanted to share one of our favorite statements. This was actually published about 5 years ago now by Dr. Andrew Ng, where he said AI is the new electricity. And just as how electricity transformed and upended many, many industries years and years ago, AI is poised to do the same. And I'm sure everyone here will agree with me, AI is certainly starting to disrupt a lot of technologies.
And a lot of this is because you have the falling price and of both storage and compute, and the availability of it on the cloud service. So with rising availability and falling costs, it means that there are more and more citizen data scientists, more people playing about with algorithms, more people tuning models, getting better results, and feeding back into the community. And that's a really important thing, is that the more available it is, and the more that people can feed into it, the quicker it grows.
In fact, to be honest with you, the signs of AI being a major disruptor are pretty clear. I'm not sure whether you saw the plans that was announced by the government last month, where they set out a 10-year roadmap as to how UK can remain and will remain a global AI superpower. So I'm not sure whether you came across this, but the reason they've done this is they know the benefits that AI can bring in terms of generating millions of pounds for the UK economy, as well as increasing productivity within the country, right? This is extremely promising and proves the government's belief in the future of AI.
So up until this point, the UK government, since 2014, has invested £2.3 billion into UK-based AI companies. Now that's not a small number, it's also not the biggest number, but this is before any of this 10-year plan. So there's obviously going to be quite a lot of government funding floating about, so if you have any cost-efficient projects, I'm sure that will help make them a little bit more cost-efficient.
I like my quizzes, so I've got a quiz for everybody here. So in terms of artificial intelligence, in terms of innovation, investment, and implementation in artificial intelligence, right? Where do you think, as a country in UK, where do you think we rank in the world? I've given you a major clue there. In the world, I've listed 3 countries. One. Any more answers?
Sorry, that is you halfway.
One? Wow, that's pretty good. I guessed 1 as well myself, but sadly, we're number 3.
So
we're number 3.
We have some way to go, sadly. But this is not done on a per capita basis. And that means that while we're behind the US and China, that we're actually doing rather well because we are a comparatively much smaller country.
We are, and I'm personally extremely excited to be in this AI journey. Right. there's a purpose as to why I've put this slide up. What is AI? And it might be a very condescending slide, but we were actually asked this question at the last conference that we attended, right? And to be fair, you get very different answers depending on who you ask.
Yes. So it's not exactly Terminator and Ex Machina. I mean, technically it is Ex Machina and Terminator, but that's not the sort of AI that we dabble in. It's not the sort of AI that you're likely to get value out of today or tomorrow, maybe in a few years.
But in terms of the data science community, AI is defined as using a huge set of tools for making computers behave intelligently. Okay. However, I'm sure you've come across many other terminologies like machine learning, deep learning, AI, and the media are very good at using this interchangeably, right? But for the purpose of this presentation, we just wanted to make clear what really AI is. And the formal definition of AI, it's that it's a general field that encompasses or includes machine learning and deep learning, okay? So another way to think about it is machine learning is a subset within AI and deep learning a subset within machine learning, therefore a subset within AI. So when we talk about AI, we mean machine learning and deep learning as well.
Yeah, and so a couple of examples to illustrate this is artificial intelligence that isn't machine learning or deep learning would be something like a simple decision tree. So you have the decision, am I going to wear a coat? And the input there is it sunny? If it is, you probably don't wear your coat. Now that's a very simple model that would technically class as artificial intelligence. And then you have the next step, which is machine learning, which is where you would have a model build itself. So instead of you programming in the decisions and you saying what the splits are, it's actually going to learn and iterate itself. And that's why we have that pattern of learning. And then deep learning is something that's modeled upon the node structure in the human brain. So we're talking about neural nets and things along this line here. And they have a lot of very, very successful applications, and they can produce some results that are very difficult to explain or interpret and understand, and they are a bit of a mystery to even the most talented of data scientists. So they're a fascinating field.
They are indeed. So we've already defined AI, but this talk is about leveraging AI in business intelligence, right? So I thought it was only fair to also define business intelligence formally. And it's about leveraging software and services to transform raw data into actionable insights. So what happens when AI meets BI?
Well, AI-powered BI is an incredibly interesting field because AI is typically very academic. We can talk about very, very interesting systems like neural nets, but to get business value out of them is hard. So what you really want is to make sure that all of your objectives are aligned with your business intelligence. So if you're looking to reduce your customer churn rate and keep more customers, then you need to make sure that that's at the forefront and not a model that will most accurately predict it. Because you can spend hours or weeks building and building upon your model and getting another % or 2 accuracy, but you need to know when to stop, and you need to know when you've gotten value out of it and when the next project is worth moving on to.
Yeah, exactly. So before talking about use cases of how to use AI in business, we just thought it'd be fair to lay out the benefits and challenges that AI brings, okay? So here I've got a slide showing a lot of figures and numbers from reputable consultancies and companies that have summarized really 2 things. How AI or businesses that have implemented AI have reaped a lot of benefits, and how organizations plan to increase their investments in AI going forward. So this is critical, really. It just shows immense benefit in past and going forwards. Having said that, though, unlocking business value is hard. And equally, there are figures there to show there's up to 87% of projects that never make it to production.
And a lot of this can come down to the siloed way of working. So typically you have data engineers who work in data engineering teams, scientists who work in the science team, and then business analysts or business intelligence that are going to work on the other side. Now, ideally, you want all of these 3 disciplines to have aligned objectives, and that's typically not the case. So you have, for example, we've talked about data scientists wanting to improve upon their models and increase the accuracy, and that's great, but if that's not aligned with the business analysts' objectives, which is to increase revenue, then that's a waste of time, and it's not going to bring you any value for the money that you've poured into a project. Also, all of these teams tend to use different tools and different sources, and they'll serve them in different places, they'll have different versions, different version control, and all of this becomes a bit of a mess to try and communicate and actually have aligned business objectives between the three teams.
So there are challenges, and as a company, we understand how these challenges, or what these challenges really is all about. And as a company, we use Databricks quite a lot, and the reason we use it is it unifies your data, it unifies your analytics and AI on one common platform. So it pretty much gets rid of your challenges of working in silos and having teams, working separately. This is also within your cloud, Azure cloud platform, so you've got your security and trust, it's all enterprise ready, and you've got your apps within Azure that you're used to.
We're not here to sell you Databricks, but I really love it as a tool, and I can't recommend it enough.
Okay, so how are companies really using artificial intelligence, and how are they maximizing value from artificial intelligence? And we're going to present 3 use cases given the time that we have. We're going to talk about recommendation systems, fraud detection, and forecasting. And the reason we've chosen this is it's versatile. It can be applied across many domains. And there are also companies out there that have had huge benefits from using these use cases. Okay? So let's take Netflix, for example.
So more than 80% of the views on Netflix are generated by their recommendation system, and that's a shocking amount. So it saves them about $1 billion every year, which is a fantastic saving. And they've introduced a few novel approaches when it comes to recommendation systems. So I don't know if any of you have been sucked into a Netflix hole that lasts 3 or 4 hours from the recommendations that they spur or the autoplay, but it happens. And part of the reason is because they are willing to continually suggest things. So they will suggest the same show multiple times, and the only thing that will change is the ordering of which they've suggested other shows and the image that they use. And that means that you don't feel like you've been recommended the same thing again and again. And so it might take them 4 or 5 attempts to recommend a show, but they've got you in the end, and you may not feel like you've been forced down that path with 4 or 5 recommendations.
Let's talk about Visa. Visa recently implemented a fraud detection algorithm, very successful, and they managed to prevent $25 billion worth of losses, and that's just in a year.
And Walmart increased their sales by 67%. And a lot of this is about efficient decision making. So they had more available stock, they had less wasted stock, they were moving stock less, and all of this is a reduction in costs and an uptick in their revenue.
So those are just brief introductions into those three use cases, but we'll describe them a lot more as we go along. So let's look at recommendations. So you might have heard recommendation systems been called recommendation engines. They're used interchangeably, and effectively, it's just a system that's designed to recommend the most relevant items to a user or customer, okay? And it can be applied to a variety of domains. And at the minute now, in terms of businesses, they are one of the most popular applications to be implemented. Recommendation systems can be loosely classified into 2 main methods. You've got your collaborative filtering and your content-based filtering. Okay, so that's me and Dan again. We are wine drinkers, okay? So I'm just going to explain how collaborative filtering works. So take me, for example. If I tend to buy white Zinfandel and Chardonnay, that's all well and good. Dan comes along and he buys similar things, but in addition to the Zinfandel and Chardonnay, he likes Pinot Grigio. So the collaborative filtering works in a way of user-based similarity. So in this case, Dan's classified similar to myself, and therefore Pinot Grigio will be recommended to me. Content-based filtering, on the other hand, works by recommending similar items. So let's take the Riesling, as we consider it similar to the Chardonnay, and in this instance, in a content-based filtering, will be recommended to me. Now, most modern recommendation systems are a hybrid between collaborative filtering and content-based filtering.
And collaborative filtering has a really interesting psychological property. So there's this concept called social proof. And it follows the idea that if you see somebody else doing something, or you know that somebody else is doing something, you're more likely to be okay with it, and you're more likely to do it yourself. So when a recommendation system generates a mathematically good recommendation for you, it's not only good in the mathematical sense that it's close to products you purchase, or it is from a history with other customers who are similar to yourselves, but it's also subconsciously telling you that other people are doing this, and it's okay, and that you should be doing it too. And that's a really powerful tool, not one that's particularly spoken about when it comes to recommendations.
So as I mentioned before, recommendation engines, it can be implemented in a whole host of different domains, right from e-commerce through to banking, through to music. And these are examples of companies that have implemented them successfully and the amount of benefits they've had from implementing recommendation systems, okay? So some companies have seen massive increase in web traffic, increased profits, through to maximizing sales. So the benefits in recommendation systems is immense.
So recommendation systems are one of the most valuable applications in AI. And the reason I'm saying this is because it can be very, very closely aligned with your business objectives. Most companies have customers, most companies have products or offerings that they would like to offer. And so if you can actually successfully recommend something from your already existing product base, then that's an easy win. And a lot of implementing AI and getting value out of it is about finding these easy wins. Oh, and they're an awful lot of fun to try and build.
Yeah, they are an awful lot of fun to build. So, second use case then, fraud detection. So what is fraud? Fraud's naughty, and it's one of the most experienced crime in the UK at the minute. And many, many different types of fraud. We're not just talking about credit card fraud, we're talking about insurance frauds, tax frauds, and there's loan application frauds as well. There's many actually. Action fraud lists a whole host of frauds out there that I didn't even realize exist. The problem with fraud is it's growing at a massive 33% rate year on year. And the cost to us as a country, just the UK alone, is £190 billion a year. Now, just to put it in perspective, to run the NHS, it costs us £150 billion. So to really get a handle on fraud is extremely critical and crucial.
It also comes with the growing e-commerce industry. So we're getting billions and billions of transactional data, billions and billions of rows of transactional data. And while people are working towards being in the cloud and having scalable solutions where you can actually trawl through that much data, the cost of the cost of false positives and false negatives that you gain from this is increasing, because you are with a small false positive percentage, you are incorrectly blocking transactions that should have gone through, and with the false negatives, that's false negatives, and with the false positives, you are, oh my God, I'm sorry. With the false positives, you are incorrectly identifying transactions as fraud, and so you are blocking them. And with the false negatives, you are not blocking any of the fraudulent transactions. That was much easier in my head than it was to say.
So why use AI in fraud detection? Fraud is unstoppable. It's constantly evolving. Every day, fraudsters are becoming more and more technologically advanced. Patterns are emerging, new patterns are emerging. The current traditional fraud engine is based on rule-based system, and typically this consists of manual written rules by an army of people, usually consists of anywhere between 1,000 to 2,000 rules. Now, with fraud detection and prevention, time is of essence. You only have a matter of milliseconds really to decide if a transaction is fraud or genuine. Now, typically, humans are slower than AI, right? I've got an example here on traditional versus AI-based methods. So with the rule-based system, you've got a fraudster making a fraudulent transaction. You've got a rule-based system, which might and might not detect it. In the cases that it doesn't detect a fraud transaction, the manual update is slow, it's laborious. It depends on an army of people trying to understand, what patterns actually cause a fraudulent transaction, updating a database. It's extremely hard to scale as well. However, there's a really good thing about having a rule-based system. It's explainable. People like it. People know the rules that have caused a certain transaction to be flagged, whether it's fraud or genuine. So that's a really good, strong point for a rule-based system. However, having said that as well, because it's rigid, it's rules, there's a lot of increase in false positives. So let's look at how an AI-based system works, right? You've got a fraudster making the same fraudulent transaction. You've got an AI-based model that will detect it, and in some cases doesn't detect it. Now, to update it, to detect patterns, AI a lot better than humans, so they do it very quickly, it's dynamic. Now, this whole process is fast, scalable, efficient and cheap, accurate. As well as advancements in AI, we can make a whole AI-based system explainable, which is really important, especially in the finance industry, right? To explain why a particular transaction was fraud or genuine. We need to be able to do this, and we can do this with AI-based algorithms. Having implemented fraud systems, we're not saying to totally eradicate rule-based systems, but the best approach is to have a hybrid system to complement your rule-based system with an AI-based system. This is how you're going to get most benefit. To summarize then, fraud detection, again, bringing you back to Visa, they've implemented fraud detection algorithm, and that saved them $25 billion worth of losses in 2020, okay?
And our final example is forecasting. And forecasting is something that is inherently difficult to do because nobody knows what will happen tomorrow, but it's something that everybody can gain some value out of. So it's typically just predicting future events, and you would use historical data to extrapolate trends and use that to, with some level of uncertainty, predict what happens tomorrow. It's a very well-researched field. I, in particular, enjoy trying to apply this in the stock market. I think everyone has been trying to do that in the stock market since the stock market's been invented. So it's a very, very easy win. If you can be accurate 51% of the time, and you always lose as much as you win, eventually you'll be a billionaire in no time. So. Oh, and it's an incredibly well-researched field as well. Like I say, people are itching to predict the future, and we all know how inaccurate weather forecasts are, so I think we all know that there's a level of
products. As we mentioned before, Walmart has seen 67% increases in sales. H&M, one of my favorite stores, 70% and cost reduction in supply chain operation. So lots of benefits to be had in terms of forecasting. So like Dan mentioned before, we've got a challenge really that offers using our solution accelerators that can prove out value in terms of forecasting for any companies that are curious about forecasting or struggling to forecast. So if you want to know more, you can come and speak to us. We've got a booth in the expo hall as well, and we'll happily speak to you after this. This is Dan's favorite slide, so the future of business is AI. So jump on board, on the train, and get in touch with us, and we'll happily speak with you. So thanks for listening.
Thank you very much for your time.